In this question we have three parts. We first need to show that the line is parallel to the plane, and then we need to make another plane that is parallel to the first plane but contains the line, and then we need to find the distances of both of these planes to the origin, and then hence find the distance between them. And because they're both parallel, they won't intersect, so it should be possible to find the distance in between them. So part A, show that the line, so I'm going to write this line, I'm going to convert this line into vector form, write it a little bit differently first. I'll set it equal to t. All of these pieces are equal to our parameter t. So then if I wanted to convert it to vector form, we'll get r equals, or xyz equals. So then if I multiply by 1, I'll get 1t. Multiply by 1, I get 1t. Multiply by 2, I get 2t here. And then I'll subtract 4. This one doesn't have 1, so that's 0, and then add 5. So this line now is, so this is the same line. So it says that this line, show that the line is parallel to this plane. In order for a line to be parallel to a plane, let's think about that. So we've got a plane. In order for a line to be parallel to it, then the vector normal to the plane, which is this vector right here, must be perpendicular to the direction of the line. So that means the dot product between 1, 1, 2 and 1, 1, minus 1 should be 0. So let's do that. 1, 1, 2 dot 1, 1, minus 1. So 1 times 1 is 1, 1 times 1 is 1, 2 times minus 1 is minus 2, which of course is 0. So there is our answer for part A. Now it says to find a vector equation of the plane in scalar product form that contains the line and is parallel to the plane. So the plane, if it needs to be parallel to the plane, it needs to have the same normal vector. So we need 1x plus 1y minus 1z equals d. And we need to find d. So all we need is a point that's contained in the plane, and this point we can grab right there. So I'm going to plug in -4, 0, and 5. So -4, 1 times -4 is -4, plus 0, and then minus 5, just by plugging in x, y, and z here. This will equal d. So -4 minus 5, d is -9. So our plane will be x plus y minus z equals -9. Alright, so our two planes are, actually does it say to write it in scalar product form? So that will be 1, 1 minus 1 r dot r equals -9. Okay, so part C. So we've got our two planes, 1, 1 minus 1 r equals 6, and we have 1, 1 minus 1 dot r equals -9. Now in order for us to find the distance to the origin, this needs to be a unit vector. Right now it has a length of √3. So if I wanted to make it a unit vector, I would divide by 1 over √3 on both sides. So now this is a unit vector, and this represents the distance to the plane. So that's 6 √3 equals the distance. 6 over √3. Same thing here, same normal vector, so that's 1 over √3, divide √3. So then we have the distance will be positive 9 over √3 is distance. So then if I want the distance in between them, we'll just add them, because this one's on one side and this one's on the other. So we'll just say 6 over root 3 plus 9 over root 3 is equal to 15 over root 3. And if you want to rationalize it, we'll get 15 root 3 over 3, which is 5 root 3.